Welcome everyone to the session on Opni. We'll be discussing Rancher's multi-cluster observability and AIOps tool. My name is Sanjay Nadavajla. I'm the engineering manager of Opni. We're currently a group of 9 strong, composed of AI engineers, Kubernetes experts, and UI folks. Let's get started by talking about observability. Observability data allows you to capture the state of your systems. The 3 pillars to observability are logs, metrics, and traces. Observability requires instrumentation of your systems to collect these logs, metrics, and traces, and the ultimate goal is to send this data to a system that can store and analyze it. Let's take a look at who needs observability. There are a couple of personas that rely on observability data and systems. First, you have your DevOps and platform engineers that set up, maintain, and operate Kubernetes clusters. They are typically responsible for setting up observability systems to enable other DevOps engineers, SREs, and developers to do their jobs. Next, you have your site reliability engineers who are responsible for application performance and reliability. They typically use observability data to reduce mean time to resolution and mean time to detection. And then you have your software developers and support engineers that rely on observability data to debug workloads. Now let's discuss the current state of Rancher observability. Rancher currently offers 2 observability tools, Rancher Monitoring and Rancher Logging. Rancher Monitoring simply deploys Prometheus, Grafana, and Alert Manager to monitor your Kubernetes cluster. It's a single cluster install, which means if you need to monitor 100 clusters managed by Rancher, you would need to install Rancher Monitoring 100 different times, and you'd get 100 Grafana dashboards and 100 Alert Managers. Rancher Logging deploys Bonsai Cloud Logging Operator, and it automates the deployment and configuration of a Kubernetes logging pipeline. You need to have a cluster output set up prior to installation, which means you need to bring your own logging backend like Loki, Elasticsearch, Splunk, etc. Now let's talk about where Rancher observability can improve. In Rancher Monitoring, a user typically wants one Grafana to inspect all of their clusters. And also we've seen in various settings that Prometheus consumes too much memory and that users want less CPU, memory, and network usage out of Rancher Monitoring and in general Prometheus setups. Now on the Rancher Logging side, you want more than just a logging pipeline. You want an experience that is more like Rancher Monitoring in the sense that it's end-to-end. You get both a logging backend as well as a logging agent in which you're able to collect and ship logs over to the backend. And you also want a UI that allows you to explore and query your log messages. Now, additionally, you also want one console where you can explore the logs of all of your clusters. So we've talked about what the current state of Rancher observability is and where it can improve. So let's now talk about how you build your own observability system. Observability systems are composed of agents and backends. An observability agent collects data from a host and sends this data to an observability backend. An observability backend stores observability data and allows users to explore and query it. So to build your own observability system using open source projects, it can be very difficult. We'll see in just a few slides why so. And if you're going to use a SaaS offering, you'll see that observability systems are often expensive and at times can be difficult too. And I'd like to point out Amazon Managed Prometheus in this example, in which AMP gives you an observability backend, but you're still responsible for shipping metrics over from downstream clusters over to this AMP endpoint. And so, since you're on your own, it can be very difficult to set up these agents. Now that we've talked about what it takes to build your own observability system, let's take a look at the CNCF cloud native landscape for observability and analysis. Now, the grayed out boxes are closed source and SaaSes, and the boxes with white backgrounds have open source components or are fully open sourced. If we take a look at the CNCF landscape for agents, I've pointed to a few of them. I haven't pointed to all of them. But the point here is that for monitoring, logging, and tracing, you're on your own. You need to figure out what agents you'd like to deploy. Additionally, the agents that you do deploy will be separate for monitoring, logging, and tracing, which means if you're trying to collect all 3 data types, you typically need to deploy 3 separate agents and manage them. If we take a look at the backends that are available to us, it's the same thing. I've pointed to a few of the popular backends, but the reason why you have different backends in monitoring, logging, and tracing is that monitoring requires a time series database, whereas logging and tracing typically requires a search database, and therefore you're on your own. You need to set up at least two separate databases to capture and store your log messages, traces, and metrics. And so observability is hard. I like to think of observability as an iceberg. Above the surface is fixing problems. This is the part we see when something goes wrong and we need to solve the issue quickly. But below the surface is preventing problems. This is the part all about studying and learning from our system so we can stop problems from happening in the first place. So that's why we created Opni. Opni makes the creation and management of observability backends and agents easy. It consists of multi-cluster logging, multi-cluster monitoring, alerting with SLOs, and AIOps. Multi-cluster logging extends OpenSearch to make it easy to search, visualize, and analyze logs, traces, and Kubernetes events. Multi-cluster monitoring extends Cortex to enable long-term storage and visualization of both Prometheus and OpenTelemetry metrics. Alerting with SLOs allows you to configure alarms and endpoints to leverage observability data in meaningful ways to allow you to make informed decisions given your observability data. And AIOps, which requires no knowledge of AI. It comes with pre-trained models which give you insights into your logging and monitoring data. Opni is the very first open source AIOps project and was mentioned in a IEEE journal last year. Now, one of the things that I want to mention is that we're not trying to reinvent the wheel in our logging and monitoring backends or even alerting. What we are trying to do, though, is make the user experience in installing backends and agents as simple as possible. In fact, our installation process for both our backends as well as our agents is not found anywhere else in open source projects. It's the user experience that's typically found in SaaSes like Datadog or Splunk, in which it's a one-click installation to install agents, and you can use either the Rancher UI or a Helm command to install our agents. Now, for our backends, they're highly configurable. Setting up OpenSearch or setting up Cortex by yourself is a very daunting task. If you don't think so, I challenge you to try setting up OpenSearch or Cortex in a Kubernetes cluster. You'll often find that figuring out how many data nodes or how many querier nodes in Cortex is something that's challenging. And so what we have is an opinionated setup in which users can go in and change certain values to make it work for their system. The part that we do bring that is novel to the open source observability landscape is our AIOps models. Rancher is a Kubernetes company. We specialize in Kubernetes, and so what we do with our AI models is we embed our expertise in Kubernetes into these pre-trained models. Now, let's say you want more than just pre-trained models and you want AI insights on your own deployments. Our AIOps allows you to select the deployments that are most important to you, and if you have an NVIDIA GPU, it will self-train on your deployments data and give you insights on those deployments. Now, if you do want to build your own observability systems using Apache 2 open source projects, Opni allows you to do so in one go. You no longer need to select all the discrete components and put them together to build your observability system. You can use Opni to create and manage your observability agents and backends. Similar to how Rancher made the creation and management of Kubernetes clusters easy, Opni does that for observability systems. Okay, so how does one use Opni? First, you determine your use case and install Opni. You have to figure out whether you want to use Opni in single cluster observability or multi-cluster observability. So if you're a Rancher monitoring user and you still want to continue using a single cluster observability tool, you can use Opni in this setting. In this setting, you care about logs, metrics, or traces of a single cluster. And so you would install Opni into the cluster that you want to observe, and it's similar to Rancher monitoring in this way. But the risk is that if the cluster goes down, your observability data, unless set up correctly, will go with it. Now, in the multi-cluster use case, you would set up Opni into a dedicated Kubernetes cluster. Let's call this the upstream Opni. Next, you would install Opni agent into all of your downstream clusters, and this will automatically connect to the upstream Opni. And this is an experience that's similar to what is offered by SaaS tools. So once you install the agent into downstream clusters, you have the freedom and flexibility to ship logs, metrics, or traces. After you install upstream Opni, you would then configure your Opni backends. Right now, Opni has two backends, Opni logging and Opni monitoring. Opni logging extends OpenSearch to make it easy to search, visualize, and analyze logs, traces, and Kubernetes events. If you're a Rancher user, you'll know that you won't see Kubernetes events past typically a day, and this is because Kubernetes events are not persisted. But if you're an operator that is trying to debug an issue that arose a week ago, these Kubernetes events would be very helpful in this debugging process. And so we thought that it would be very helpful to actually persist this within our logging database. Now for monitoring, it extends Cortex to enable multi-cluster long-term storage for metrics. And so for both, we provide RBAC configuration that will allow you to set up multi-tenancy. After your backends have been set up and you've already installed Opni agent into your downstream clusters, this is when you can enable capabilities inside of your agents running in downstream clusters. And so for the logging capability, the prereq is that the logging backend is set up. And similarly for the monitoring capability, the prereq is that the monitoring backend is set up. And so all you have to do is go into the Opni admin UI and you would go into the respective backend. So for logging, it would be logging. For monitoring, it would be the monitoring backend. And what you do is you select all of the agents that you want to enable log shipping or metric shipping for, and you hit install, and it's as simple as that. If you would like to stop the shipping of logs or metrics of a particular cluster, go back to the respective backend page, select the cluster, say stop shipping, and as easy as that. You no longer need to switch into each of those clusters and disable agents manually. Now, once you have your logs and metrics being shipped over, you can head over to the Opni AIOps page. Opni AIOps comes with AI models that ingest observability data to reduce mean time to detection. Opni AIOps produces insights for logs, metrics, traces. For logs, we enable anomaly detection on the Kubernetes control plane, Rancher, and Longhorn logs. And we also provide a UX that allows you to select the deployments that are most important to you. And if you have an NVIDIA GPU enabled in the cluster, Opni will self-train a model that will allow you to find anomalies inside of your workload deployments. Similarly, for metrics, we have abnormal chart patterns and time series. This is yet to be released, but look out for it soon. And for traces is a data type that we had enabled previously and disabled. We're planning on re-enabling it towards the end of the year. But once traces are back in the system, we will be able to do root cause detection with Opni. Opni alerting and SLOs allow you to create and manage alerting alarms, endpoints, and SLOs. For Opni alerting, you can select endpoints that are meaningful to you. So these are endpoints like Slack, email, or PagerDuty. If any of you want any additional endpoints, let us know and we'll add it. Alarms are used to evaluate whether a condition should fire a notification to a configured endpoint. And so the alarm types that we allow users to enable are Prometheus queries, kubestate, agent disconnect, downstream capability, and monitoring backend. Now the last three are specific to Opni. First two, though, are where users can configure metric queries and kubestate conditions that will allow them to monitor their Kubernetes resources as well as their metrics. And so observability without Opni can be very expensive if it's a SaaS, because SaaSes are consumption-based models and it's hard to forecast how much you're going to spend. Without Opni, it's difficult to set up if it's open source. It's difficult to create and manage observability backends and agents. SLOs are difficult and require SMEs. AIOps is very difficult and requires machine learning engineers to get started, but with Opni, it's completely open source, it's easy to install, it's easy to create and manage observability backends and agents, it's multi-cluster and multi-tenant. SLOs are made easy, comes with AIOps, it's a Kubernetes first application, and it comes with Rancher integration. And so going back to our personas, your DevOps and platform engineers would use Opni to set up and manage observability systems. Your SREs would use Opni for logging, monitoring, alerting, SLOs, and AI insights to reduce mean time to resolution and mean time to detection. Your software engineers and support engineers would use the metrics and logs found in Opni to debug their workloads. And lastly, Opni gives you full flexibility. Backends and agents are built on proven open source solutions. I see a lot of observability open source projects out there in the ecosystem today, but many of them are being built on analytical databases and not databases that have proven themselves over the last decade. For logs, you need a search database, and for metrics, you need a time series database. And oftentimes, when you mix the two together, you get a solution that's not robust for the use case of both logs and metrics. Therefore, we are building Opni on the same stack that Amazon uses to build Amazon Managed Prometheus, AMP uses Cortex, and Amazon OpenSearch. Amazon is a heavy contributor to OpenSearch, and we have a team member is a maintainer of the official OpenSearch Kubernetes operator. Now let's go to a case study. Hosted Rancher uses Opni today, and what folks over in Hosted Rancher started seeing is that Prometheus was using way too much memory, and they needed a smaller metric footprint. Prometheus was taking up way too much RAM inside of the clusters that are managed by Hosted Rancher. And so Opni v0.10 gives users a choice between Prometheus and OpenTelemetry. And so what this means is once you install the monitoring backend and you enable metrics in all of your downstream agents, you can select and switch between OpenTelemetry and Prometheus. Now, the difference between OpenTelemetry and Prometheus are pretty significant. Prometheus comes with a time series database, whereas OpenTelemetry is purely just a collector. Prometheus uses these data structures called write-ahead logs, and these write-ahead logs is how Prometheus is able to build up metrics into time series, whereas OpenTelemetry does not build up metrics using write-ahead logs. Instead, it computes deltas in between timestamps. So because it's only computing deltas and not storing up these write-ahead logs where series are accumulating and accumulating, and also because Prometheus adds labels to everything, you see high cardinality data being built up in Prometheus. And so when we switched over from Prometheus to OpenTelemetry within Hosted Rancher, we saw huge improvements. We saw RAM savings of 40 to 90%, CPU utilization savings of 25 to 60%, and network throughput be reduced by over 60%. And so the takeaway is that users should be able to select what tool works for them and their setup. And Opni allows you to do that in a very easy fashion. You can switch between collectors very quickly and easily and switch back when needed. Additionally, what this opens the door to is if you are running these agents in edge environments and you do need a temporary time series database in Prometheus, because you have limited internet connectivity and you only want to flush metrics to upstream Opni when you have internet connectivity, you can do so. Opni makes the creation and management of observability systems easy. It allows users to configure these systems in ways that work for them. So let's talk about what we're building for Opni in the future. We're planning on GAing towards the end of the year or early next year. And so we realize that authentication is something of high concern for everybody. And so that's a feature that we're currently working on to make the auth story as cohesive as possible because we have disjointed databases. Another thing that we're working on is the scalability within Opni Gateway. We've tested with about 20 downstream clusters, but we want Opni to be able to scale massively. And so that's something that we're currently working on in preparation for GA. Opni logging as a vector database. We've seen open source projects like Milvis and other vector databases take off recently with the huge use of LLMs. And OpenSearch can be used as a vector database in a hybrid search where you need both lexical and semantic meaning being captured in input user queries. And so we are working on a feature that will allow you to enable Opni logging as a vector database. Additionally, we're introducing Ray into the system to enable multi-GPU support. This will make our AIOps pipeline a lot more robust as well as extensible, allowing you to leverage 0 or multiple GPUs. And so with that, I'd like you to check us out. Go try Opni out for yourself. You'll see on the documentation that there are videos to how you can install, set up Opni. So please go check that out. Go check out our GitHub repo. We're actively working on different features and issues. So please feel free to file a new issue if you are having any trouble. Post on our forums within GitHub or join our Rancher users Slack channel under hashtag Opni. And we're looking forward to hearing from you. Thank you for attending today's session on Opni. If you would like to get a demo from us, please reach out and we would be more than happy to do so.